Hello, and thanks for tuning into our presentation. We are EOLAS, a Scottish-based R&D company that specialises in creating technologies that facilitate ecological research. EOLAS has collaborated with NatureScot and the CivTech Accelerator Programme to conduct research on the remote tracking of red deer via satellite imagery, complementary neural network architectures, and probability adjustment. Traditionally, deer counts are performed via helicopter. This technique yields very accurate numbers, but it's costly and time consuming. Even though it's not the most expensive technique, it is the most polluting. These figures are based upon the amount of CO2 produced per square kilometre of land observed. Unsurprisingly, satellite observation is far better environmentally and is thus the most appealing method. Our research aims to use 30cm imagery gathered from the WorldView 3 satellites. We've also been using 25cm aerial imagery from GIT mapping, as this has proven to be comparable in terms of image quality and feature detection. Archival imagery allows us to circumnavigate poor weather conditions, and in the future, we'll utilise Pleiades Neo and WorldView Legion constellations for our research. To begin with, we choose a small sample area. From this resolution, it's impossible to locate any red deer. We therefore tile the sample region into a series of smaller images. From here, we proceed to manually label as many red deer as we can find. At this point, our dataset is relatively small when compared to other similar projects. We use what little data we have in order to train a modified YOLO object detection algorithm and use it to scan the same sample area. The resulting better than nothing model yields detections present in the training data and others not previously found. These new detections are verified by a human and added to the previous training data. This cycle allows us to semi-automatically grow our training data, allowing us to train more accurate models. And the cycle continues. This process is repeated on other small sample areas until we eventually use the model to infer much larger regions. Resolution will always limit the accuracy of projects such as this. High-resolution images have far more features for a model to generalize from, whereas in our images, the deer are only between 5 and 15 pixels in size. Growing our training data can help mitigate against this. Our in-house augmentation pipeline has been carefully chosen as to not overly modify the features of our targets. We use a combination of rotational, translational, and PCA color augmentation to supplement our original images. We then utilize UNet in order to obtain more information about the landscape we are studying. Here, UNet has successfully detected woodland and trees, and these highlighted areas represent anything urban or man-made. Referring back to our previous example, we see that the model has classified a high number of potential deer. We first add our segmentation layer. More data allows us to determine detection validity. Objects found in low moorland are more likely to be deer than those found in urban areas or water. This third layer was created using Landsat thermal band data and represents temperature fluctuations over the area. Finally, a QGIS hillshade layer adapted from a digital elevation model is added to represent wind speed. We utilize Bayesian filtering along with ecological insight from these additional layers to adjust the confidence levels of our detections. Prior to any probability adjustments, detection is skewed towards lower confidence values. This is due to the high number of landscape features that have been falsely classified. After probability adjustments, the distribution becomes skewed towards higher confidence values. Thus, erroneous detections are removed and we are left with objects of high confidence. This filtering is the culmination of combinational neural networks and human expertise. Thank you for tuning into our presentation. We would be happy to answer any questions you may have, and if you're interested in our work, please don't hesitate to contact us.